Hey guys, today we are going to do some application problems. We're going to do a few of these together, and then you're going to be doing some in class with me and then independently. The thing to remember here is these are real world applications. So most of the time, negative numbers are not okay. You need to double check that and make sure if you do get a negative number that it fits in with your problem. The other key thing here is make sure if you can to draw a picture. Number one, the width of a rectangle is 6 meters less than its length. All right, I'm going to underline that because that's important. If the area of the rectangle is 112 meters squared, here's your question. Find the dimensions of the rectangle. So it's a good idea for you to analyze your problem and to figure out as much as you can before you get started. So we have a rectangle. And the width is 6 meters less than the length, which means the length is x. Area of a rectangle is length times width. So that's x times x minus 6, and the area is 112. So that's x squared minus 6x. We're going to set it equal to 0. And what multiplies to give us negative 112 and combines to give us negative 6 is negative 14 and positive 8. We're going to set each of those equal to 0. And x is 14 and x is negative 8. If we plug negative 8 into our length or our width, we get a negative value, and we cannot have a negative length or width. So x is equal to 14, which means the length is 14 meters, and the width is 14 minus 6, which is 8 meters. The other thing you have to remember is that these problems most of the time are going to have a unit of measure, which needs to be in your answer in order for it to be complete. So length is 14 meters, and width is 8 meters. So we can write that as 14 by 8. Problem number 3, the dimensions of a rectangle can be expressed as x plus 6 and x minus 2. If the area of the rectangle is 65 inches squared, find the dimensions of the rectangle. This problem lays everything out. So there is no drawing needed unless you just want to. So area is 65. Dimensions are x plus 6 and x minus 2. Because you are multiplying, it does not matter which is first and which is last, because you can multiply forwards and backwards using the commutative property of multiplication and get the same value. So I'm going to do 0 equals x squared plus 4x minus 12 minus 65 and get 0 equals x squared plus 4x minus 77. That's an easy one to factor. X plus 11 and x minus 7, and set them equal to 0. And x is negative 11 and x is 7. And if we plug negative 11 into either one of those, it gives me a negative value. So x is equal to 7. When you plug 7 in, you get 7 plus 6, which is 13. And this one doesn't. Yes, it does, inches, 13 inches. And then x minus 2, 7 minus 2 is 5 inches. Dimensions will be written in that manner. The hypotenuse of a triangle is 1 foot more than twice the length of the shorter leg. The longer leg is 7 feet longer than the shorter leg. Find the dimensions of the triangle. So we're going to draw our triangle. We have a hypotenuse. We know we have a right triangle. The hypotenuse is 1 foot more than twice the length of the short leg, which means the short leg is x and the longer leg is 7 feet longer than the shorter leg. Pythagorean Theorem, x squared plus x plus 7 squared is equal to 2x plus 1 squared. So x squared plus 14x plus 49 is equal to 4x squared plus 4x plus 1. So that's 2x squared plus 14x plus 49 equals 4x squared plus 4x plus 1. Setting it equal to 0 gives you 2x squared minus 10x minus 24. We're going to factor out a 2. I'm going to go up here to the top. So we have 2 times, that would be x minus 8 and x plus 3. So x minus 8 is 0, x plus 3 is 0. So x is 8, x is negative 3. Plugging in negative 3 is going to give us a negative value. So the short leg is going to be 8. Doesn't give us dimensions. The longer leg is 8 plus 7, which is 15. And the hypotenuse is 16 plus 1, which is 17. And remember that hypotenuse should always be the longest leg. That's why it's called short leg, longer leg, and then hypotenuse. Taking a look at problem number 8, given the diagram below, if the area of the shaded region is 59 inches squared, what are the dimensions of the outside rectangle? So the outside rectangle is what we're looking at here. So we're going to do area equals length times width of the outside minus area equals length times width of the inside. And then we know that the area of the shaded is 59. So we have x plus 6 times 2x minus 1 minus x times x plus 3 is equal to 59. So we're going to multiply all that out, FOIL method. Distributive property, don't forget that negative outside means you need parentheses. So combining like terms, x squared plus 8x minus 6 equals 59, and subtract 59. And factor x plus 13, x minus 5. So x plus 13 equals 0, x minus 5 equals 0, x equals negative 13 and positive 5. Negative 13 is going to give us a negative value, and the outer dimensions, 5 plus 6 is going to be 11 inches by 10 minus 1 is 9 inches. And the last problem we're going to do is a consecutive integer problem. This one is consecutive odd, even though it sounds weird. If you think about it, 1, 3, 5, 7, those are consecutive odd integers. To get from 1 to 3, you have to add 2. So that would be x, x plus 2, x plus 4, x plus 6, etc. I know that's kind of confusing, but even though it's odd, that's the pattern you will choose. Even would be the same way. So 2 consecutive positive odd is going to use x and x plus 2, such that the square of the smaller integer added to 3 times the larger integer is 24. So the first is going to be x, and the second is going to be x plus 2. So the square of the smaller integer added to 3 times the larger is equal to 24. So x squared plus 3x plus 6 is equal to 24. X squared plus 3x minus 18 is equal to 0. Keep in mind these are positive, odd. So we factor x plus 6, x minus 3. Set each one equal to 0. X is negative 6, x is positive 3. Because it's positive, the negative will not work. Consecutive positive would be 3 and 3 plus 2, which is 5. We will complete the remainder of 1 through 10 in class. Don't forget your question box, and I hope you have a great day.